So the last part I want to look at is properties. So let's just talk about them. All right, for the properties, domain is your x value. If you look at a cube function or cube root function, you're going to get this little snake looking thing, right? So the domain, all the numbers are going to be used. All right? So that will be all real numbers. And we would write it, if my pen will work, we would write it as negative infinity to infinity. Okay? Our range would be the y's. There it went. And you notice, because it's this snake, we're going to use all the y's. Okay? And in your parent function chart, you should see that. All right, now for this particular function, we do not have a distinctive turning point. So max and min, we don't need to name. All right? We do see an x-intercept at -1, and we see a y-intercept at 1. Actually, that's -1/2, because those are half marks. Then let's look at the graph itself. From left to right, it goes up the whole time. So it is increasing from negative infinity to infinity. Okay? Now let's talk about this positive and negative that we struggle with. This is where it's negative. Okay? So we'll talk about the positive in just a second. But the negative portion is from negative infinity until we get right here at the 1/2 mark. Okay? And then all of this up here is a positive position. So we're starting at that negative 1/2 mark, and we're going to positive infinity from there. Okay? This is the positive portion of the graph. In behavior, so remember we say as x approaches negative infinity, that's here, y in this case, f of x, is approaching negative infinity. It's going down. As x approaches positive infinity, that's this end, f of x, or y, is approaching positive infinity. Okay? So you're looking at the ends to see what direction they're going in. All right? Let's look at this one. It says, what is the end behavior? For a radical, a square root function, you have a distinctive end and you have a continuing end. So the end behavior that this is looking for is where x approaches either negative infinity or positive infinity. In this case, it's approaching positive infinity, and f of x is approaching positive infinity as well. For the domain and the range on a square root function, you have restrictions. So let's just look. Let's look at the, we'll look at the x first, the domain. So for domain, it starts right here at 2. And it includes 2. And then it moves this way to infinity. Okay? Now let's look at the range. The range, remember, is the y. So the range starts down here at -3. And it moves upward into infinity. So the domain had a restriction. Domain didn't start until 2. 0 was not in the domain for this graph. Okay, and then the range had a restriction. It didn't start till -3. Okay. So let's look at this section here. I think it's the same one you had. We did that one yesterday in our other function. Okay, let's look at one more example of properties, and that'll be it. Domain, this is an absolute value. Those are the x's. Notice if I've had arrows going left and right, so that means domain is everything, all real numbers. The range is restricted starting at 2 and then goes to infinity from there, because it does continue upward. Okay? Now, since this is the lowest point on the graph, we would call this a minimum. And the minimum value is at -1, 2. This graph does not cross the x-axis, so there are no x-intercepts. There is, however, a y-intercept at 3. Okay? Now, let's look. For increase and decrease, if we read our graph from left to right, we go down first. So let's talk about the decrease. We're starting at -infinity, and we move till we get right here. This is where we change directions to -1. Then we increase because we turned around. Now we're going up. We're going up from that -1 to the rest of the graph, which is infinity. Now let's talk about positive and negatives. There is nothing on my graph below the 0. So there are no negatives. There are only positives, and they are from -infinity to infinity. Okay? In behavior, our favorite one, as x approaches -infinity, y, or f of x, here's x going to -infinity, y is going up, so it's going to positive infinity. As x approaches positive infinity, f of x, here's x going to positive infinity, y is still going up. F of x approaches positive infinity. So that's a review of what's on the test. Go back through it, look at your review sheet, make sure you've answered everything correctly.